Now let's take a look at these two examples. We want to simplify this Boolean expression into a simpler expression. Now here I'm going to use the alternative symbols. And the reason that I do that, it's because some of these properties from Theorem 10.1, they are very similar to the traditional properties of algebra. So I'm going to replace the OR symbol here with the addition symbol, and the AND function, I'm going to replace it with the multiplication sign. They still mean OR and AND, but this makes it easier for us to remember the properties of the Boolean algebra. Now, there are two things we could do here. I'll try this first property, which is distributing the addition into the multiplication. So I'm going to distribute x plus into x times y. So x plus x becomes x plus x times and x plus y. Then this property here is the idempotent property, where it says that x plus x is actually x. Look how interesting this is. We converted that expression into this one. Now let's distribute again. This time it's x times and into x plus y. X times x plus x times y. Now recall that x times x, it's another of the idempotent properties. X times x is actually x. And this is x times y. So that didn't help much, because now we came back to the first expression that we started with. So we're going into in circles here. So let's try something else then. One thing we can do here is to apply property G, which it says that x is actually x and 1. Notice how similar this is with our traditional algebra, right? When we look at x as a real number, any real number is itself times 1. But we are not doing the regular algebra here. This is the property G from the theorem. So x is x and 1. Now the reason that I want to do that, it's because I want to quote unquote factor x out. Now in Boolean algebra we don't have that concept of factoring, but this is actually from the distributive property, where we simply are going the reverse order. We're going backwards into the distributive property. So this expression here comes from x times 1 plus y, or x and, in parentheses, 1 or y. Now, in the parentheses, 1 or y, this is actually 1. And this is property H in the theorem. And also x and 1 is x. And that's property G in the theorem. So notice that this part here didn't help much. So let me circle that. So we ended up in circles here. We came back to the same expression as the beginning that we see at the beginning. So we tried this different approach. So that expression is equal to x. Let's do the second example. Here again, I'm going to replace these symbols with the alternative symbols. So this is multiplication, x plus y. Let's go ahead and apply the distributive property here. X times x plus x times y. And now this is x times x, or x and x. This is one of the properties in the theorem. This is actually x, and this is x and y. Well, now we're back into the example one. We already know how to simplify this expression, and this is simply x, according to example one.